going to look at finding the least common multiple, or LCM, and then use that to help us solve rational equations. The least common multiple is kind of what it sounds like. It's the least number, smallest value that is a multiple of the values in question. You used a similar concept to this when you add and subtract fractions, so that's where you've probably seen this most. Least common denominator is the LCM, or least common multiple, of those denominators. So it's the smallest value that is the multiple of both of those, or in some cases you might be asked for three different, to find the LCM of three different things. In this case I have two terms here, 6p and 9m squared. So I want to find the least common multiple of these. I'm going to treat the coefficients separately from the variables. So I'm going to think about 6 and 9 first. What is the least common multiple of 6 and 9? Some of these, for smaller values, it might be easy enough just to kind of think, okay, well, what does 6 and 9 both go into? Well, 6 goes into 12 and then 18. 9 goes into 18, so you might be able to see that that's 18. Another way that you could do this is you could take 6 and kind of list it out. 6, 12, 18, 24, etc. if you're not sure right offhand, and then do the same with 9. And then the smallest one, whenever you get to a point where you see something in common, then that is your LCM. So that would be one kind of like, if it's not coming to you, you could just actually write out the multiples until you figure out what that value is. So in this case, it's 18. And then the p and the m squared, there is nothing in common with p and m squared. So if there's two separate variables, it's just going to be the product of those two things. So it's just going to be p m squared. P m squared is the smallest value that will divide both 6p, just p, since we're not looking at 18, and the m squared. So that would divide p, and it would divide m squared evenly, and that's the smallest value that would do that. So that's it. That's finding the LCM. To find it for 7b squared and 5c cubed, the smallest number that 7 and 5 both go into is 35. Again, in this case, it happens to just be the product of those two numbers. 7 and 5 is 35. But again, if you weren't sure, you could do this method where you could list out all the multiples of 5 and list out all the multiples of 7 until you ended up with a common value there, the smallest common value. So it is 35. And then in this case, I have a b squared and a c cubed. They are different variables, so the smallest value that will divide both of those is just the product of that, so b squared times c cubed, and that's it. All right, for this one, 8 and 12. The smallest number that divides 8 and 12. So 8 is, the multiples of 8 would be 8, 16, 24, 32, etc. 12 would be 12, 24, 36, etc. The smallest number that divides both of them is 24. So we're going to use 24. And then with the m's, these are the same variable. So this is m squared and m. M squared means 2m, so m times m. And m, we just have one of them. So the smallest value that divides both of those evenly is m squared, because m squared divided by m squared is 1, and m squared divided by m would just be m. So m squared divides both of those. This is going to be kind of a trick for this. It's just remember that the LCM, when you're dealing with a variable, is always going to be that variable to the highest power that appears in any of the expressions that are under question. And that would be m squared. All right, so that's it. So it's just always, so if you had like a, let's say that you had x squared y cubed and x cubed y, the LCM of these would be, so you're dealing with the x, you have more than one variable here, but you have 2 of them here and 3 of them there. So the smallest value that would divide both of them would be that x cubed, because x cubed divided by x cubed would be 1. X cubed divided by x squared would be x times x times x divided by x times x. You'd be left with 1x. So that value does divide both of those evenly. And then the y's would be y to the 3rd. But again, the trick is just to remember that it's the highest exponent that you have. So x squared is, x cubed is the highest that you have between the two terms, and y cubed is the highest. So it's just the product of those two. So even if you had 4 variables in the expressions that you're dealing with, you just kind of treat each one separately and see what the number of times that each one occurs as a factor in each one. and the most number of times that it occurs, that'll be the exponent for the LCM for that variable. All right, find the least common denominator. So taking this to fractions, we are looking at rational expressions in this unit. So looking at the fractions, in order to find the least common denominator, the first thing we want to do is actually get it in factored form so that we can see what our factors are. Because we're trying to take the value that divides those evenly, so if we can see those factors, which means things that are multiplied, then we'll be able to see those multiples. So I'm going to rewrite this 4x plus 12 as 4 times x plus 3, so I'm just factoring out that GCF of 4. And then this is 8x, so I'm just kind of treating this and taking those denominators and treating it like these. So first thing I'm going to do, notice that you look at the factors here. The factors here are 4 and x plus 3. And here the factors are 8 and x. So if I look at the coefficients, 4 and 8, the least common multiple of those is 8. 8 divides 8, and 8 divides 4 evenly. So the LCD, I'm going to start with 8, and then I'm going to take each factor the most number of times that it occurs. So the other factor I have x plus 3. It occurs once, so I'll take it once as a factor, and then I have an x. It occurs once, so I'll take it as a factor. So that is your answer. Usually we see this written, we would see it written as 8x in this order, but it doesn't have to be. Either of those are equivalent. All right, so that is the LCD of that one. Doing the same thing here, I've got x plus 3, and I'm going to factor out the 6 here. So that's 6 times x plus 3, and factoring those out. So notice here that the x plus 3 I have in both of these. So again, I mentioned up here that you want to take each factor the most number of times it occurs. The most number of times that x plus 3 occurs is once. So I'm only going to need to take it once. So up here I needed to take the x plus 3 and the x because they were individual factors, unique factors. But here I have the same factor, so I only need to take it once because that will be the least common multiple of x plus 3. Also, I have this 6. There's no leading coefficient here, so the LCM as far as 6 is just going to be 6. And x plus 3, like I said, occurs once, so it'll just be the product of 6 and x plus 3. That is the smallest value that will divide both of those evenly or is a multiple of both of those. All right, so that is finding the LCM.